What's going on, everybody? Brian Mann here, Hands-On Auto Training. End of day, December 15th, 2021. Don't forget, it is not too late to sign up for the core or premium memberships to be entered in to win this U-Scope kit. That drawing is going to be this Friday for any premium or core members, so don't forget, get signed up there. Guys, I got to tell you, I really enjoy comments in the comment section. Yesterday, got a lot of feedback from our demonstration. People liked it. But also somebody was asking about shorted injector. Wouldn't that look like a shorted injector? And actually, no, it wouldn't. And I wanted to demonstrate why. In the comment, I think I said we'd have an instantaneous current rise, and I think I said I don't think we'd see a voltage spike either on our inductive kick. So I'm going to go ahead and demonstrate that here. Just so you know the setup, I didn't do a good job of showing you what we're doing here. This is a picoscope amp clamp. We're going to put this to the 20 amp scale. That means that 100 millivolts equals 1 amp. So I'm going to go ahead and zero this out, clamp that on there. Also, I do have a power supply over here that we can put this to 10 volts, 12 volts, whatever. My power supply maxes out at, I think, 3 amps. Now, I'm expecting some higher current flow. However, to protect my circuits and stuff, I don't want to damage all this stuff, I am going to use a 5 amp fused when we short this injector out to do our demonstration. Being that my power supply can only put out 3 amps, I don't know how long it can do it. I haven't done enough experimentation to see what happens when I put it higher. I'm just going to add another 1,000 microfarad capacitor on our 12 volt power rail here. I'm hoping that will be able to just absorb a little bit of the voltage change, if you will, or the demand on the circuit. I'm not an electrical engineer by any means, but I'm just messing around here. So what we have here is this fuel injector. This is our bad injector. I ran a jumper wire that's back probed into this through that fuse, and that goes over to our breadboard. I have a momentary contact switch. Let me flip this around. There you go. I have a momentary contact switch right here that I can push that will actually tie the yellow and the red wire here together, and then this wire goes right back to our injector. So pushing this button will actually tie these two terminals together and create a short. So I'm hoping I'm not going to damage any of my equipment here, but let's give it a try. I'm going to turn on this circuit. There we go. We're running about, I've got this about 12.5 volts right now, and you can see, let me just hit the stop button. I want to show you what we see here. We do have our current, and we're right at the 100 millivolts. Our green scale here is at 100 millivolts per division. So you can see we're just about right around an amp, 1 amp of current flow right there. Let's go ahead and hit the run button again. But before I do that, our voltage, let me zoom in here. I should have done that first here. You can see our voltage comes down to nearly zero volts when this circuit turns on. And then we have an inductive kick. I can go ahead and, let's see, I can lower this down here so you guys can see that. There you go. Put this to 5 volts negative. There you go. So we have 5, 10, and about 12.5 volts. Gets grounded. Circuit turns on. It turns off. We have our inductive kick. As the circuit gets turned on, we have our current flow. Now, just so you guys know, like I said before, we have a current ramp on the good pattern. This is a good one here, and then we have a current curve on this bad one. But let me go ahead and hit the run button, and let's get some more time on this screen. And I'm going to go ahead and create this error. In those comments, like I said, somebody had a comment about that. Let's go ahead and take a look at what this looks like. I'm going to short it out. So I pushed that button just for a second. I'm going to go ahead and do it again. There you go. I'm going to hit the stop button. Shut this down. Let's go ahead and take a look at this. This is a good pattern here. We have our injector getting turned on, current curve, current ramp, and here's when it gets shorted. So if we're at about 1 amp here, that's 2, 3, 4, 5, 6. We go 6.5 amps we're getting up to really quick. Now, do you see the instantaneous change in the current flow? Check this out. If I zoom on this, this is our good, well, not our good pattern, but it's our better pattern. We have a current rise. It's not necessarily a ramp, it's more like a curve. But that is a normal current curve for a coil wire. Also, anytime we have a coil wire that's not shorted at all, we'll get an inductive kick when it turns off. Now, this is a dead short that I created here, right? I mean, we're talking about a dead short. Let's go ahead over here and take a look at what that looks like. And you can see this current flow instantaneously goes up. I mean, if I zoom in here, it is a nearly instantaneous vertical rise in our current. Now, I'm maxing out the scope resolution probably at this point. We're at, let's go over here to 20 microseconds per division, I think. You can see that's an instantaneous rise. If we zoom out to anything normal that we'd be looking at like that, we'd say that's instantaneous up. So the other thing that was very interesting as I was messing around here, experimenting, check this out. With this being dead shorted, our current flow goes up, but our voltage is not going down all the way. So I think what we should do real quick here is maybe add a resistor. I found this 1 ohm resistor. Now this is only a 1/4 watt resistor, so we might be letting some smoke out, but I think the current flow is only flowing for such a small amount of time that it really won't matter here. I want to see if this voltage comes down any further. Let's check this voltage here. Let's go. We're only dropping this down to 8.5 volts from our source voltage of 12.7. So that's kind of interesting that we're only dropping 4.3 volts down. So let's go ahead and turn the circuit back on. And I want to basically, I got this cursor up there, so as I turn the circuit on and hit the run button, I can go ahead and turn my voltage up to the same point. The same point there that we had before. And let me go ahead and hit this button here. Now we're shorting this with a 1 ohm resistor. I'm really curious to see if we have more of a voltage drop still. Turn this off. Okay, this is interesting. So putting that resistor in line across, basically putting a 1 ohm resistor across this, you can see we still have current rise, 1, 2, 3, 4, 5, 6 amps. Not quite 6.5 amps or whatever we had before, but this is just right about 6 amps. But we have more of a voltage drop. Check this out. We can see here. Because when we talk about electricity, basic electricity, we always talk about all the voltage drops in a circuit add up to the source voltage. That's what we're taught, and that's what I teach. Now, if you think about this, when we had that dead short, we were only showing, on our ground side, we were showing higher voltage. So that means that somewhere else, you know, on the ground side of this, that there's another voltage drop past the point going back to our source of our test point, should I say. This gets confusing to think about, but it's really cool stuff if you just want to analyze it a little bit. And as we added that 1 ohm resistor as a short across this circuit, now we're dropping more of our voltage on that side of the circuit from where we're probed into. So it's really cool to think about. We're lowering the current flow. Anytime that current flow is resisted, a voltage will be dropped across that resistance. To add in another 1 ohm resistor in series. So I'm just really curious here to see how much further this goes down. So I'm keeping that cursor right there, and we're going to hit the run button, and I'm going to get this till our voltage is up to there. And let's go ahead and short this out again. Yeah, put more time on the screen so I can see what's going on here. Let's take a look. Now you can see with 2 ohms of resistance in this circuit, our current flow is not going as high. Our current flow is only at 1, 2, 3, 4 amps. And check this out. You're starting to see what looks like that curve coming back. That's because I believe more of the current is able to flow through the inductor. You know, when we have a dead short, all the current flow is going to want to go across the dead short. As we increase the resistance on our shorted side, we're forcing, or should I say the electrons want to take the path of least resistance, and it's starting to be through this coil of wire. That coil of wire has inductive properties, and that's why you see the current flow taper off. Pretty cool stuff. Let's go ahead and see here. I think we could see here that we start to have a little bit of a kick. Let's see. It doesn't really kick high, but there's a little bit of an inductive kick because you're seeing the other side of that coil. You're seeing that a magnetic field collapse around that inductor as we turn off the voltage. So I'm kind of playing tricky with you guys. It's only quarter to 10 in the morning here. I got to prepare for another class, and I'm hoping to get out and do a couple mobile jobs. This time of year, it usually gets kind of funny with the mobile business. I've been in the mobile business for what, going on 12 years or so now, and you know, it just goes up and down. You'll have days that you're so busy you can't keep up, and then days there's nothing going on, the phone doesn't ring. So you just never know what's going to go on. I've learned just roll with the punches and try and fill my time doing other things. So I almost forgot, premium members, we have our meeting tomorrow night at 8 p.m. Eastern Standard Time. Just so you guys all know, in the future, coming up next year, I'm probably going to be doing one of the live premium member meetings per month at 9 p.m. Eastern Standard Time to help the guys on the West Coast out a little bit. So I'm going to go ahead and go off script here and go on a little rant. If you like this type of content, what you're seeing here, there's more of that, quite a bit more on the core and premium membership websites. I'm just showing you guys what's going on here because the past few days of my mobile business have been slow. And if you don't know, way back in, what was it, July 21st of this year, I made a commitment to myself. I said, I'm going to make one end-of-day video every single working day for the rest of this year at least. And if people like it, I'll keep on going. And I don't like it when I don't have something good to share, so that's why I kind of filling in when I don't have a lot of stuff out in the field, mobile diagnostics and programming wise, you're getting some of this. So if you like this type of stuff, let me know. We'll see what we can do. I'm thinking about really working on like a pop quiz thing once a week. I should probably find one way to make something once a week to do a little quiz, and then we'll answer it the following day. Maybe it'll be Pop Quiz Monday. What do you think about that? And then we could have the answer on Tuesday. Just so you guys know, once again, that U-scope drawing is on Friday. And what else did I have to say to you? Oh yeah, like, subscribe, hit the notification bell. You guys have a great day. I hope everybody's doing well this Christmas season, or whatever you celebrate. I hope you have a happy holiday, but I celebrate Christmas. And sometimes people are forgetting the meaning of Christmas. We get all this commercialized baloney going on, and I mean, shopping and parties and da-da-da-da-da. It just gets to be overwhelming, so I'm hoping you can take a deep breath, take a step back, enjoy this Christmas season, and have a great day. Bye-bye.